Hai, Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera. We are from Group 1. We'll present about protection scheme of a two-source distribution system. So for today's agenda, we have introduction, problem statement, design and simulation, technical specification, timeline, critical path methods, cost and standard, and conclusion. For organization chart, we have IZZAT Danial as project director, FAHMI as operation manager, DAREETIA as a senior electrical engineer, Aini and FIRDAUS as electrical engineer. So for introduction, first is designing and developing a protective system, which is to detect and isolating fault in electrical system. Second is a protective system set to identify defect or possible hazard, which is hazard in lines and other component. Next is protective release are key in detecting faults and triggering the right response, which is to protective relay are designed to detect overcurrent and overvoltage. Next is to shield the power distribution system against excessive current, which is our aim is to reducing the risk of tripping or power loss. For problem statement, we got two problem statement that we got is which is various issues such as short circuits, sudden change in high load, and distribution during switching operation in fault currents. And the protection system should coordinate and communicate with other protective device in the network to ensure the fault.
Nakimi for presenting our introduction and problem statement. Now, my name is IZZAT bin Muhammad ANUAR, matrix number CN2022, represent our design for our protection scheme of a two sources distribution system. Okay, as you can see on the screen, this is our design. Consists of two generator and one step down transformer, our 4 load. Before the transformer, our 1 load, and after the transformer, I have 3 loads. Okay, this is our equipment and description, which you can see generator 1 and generator 2 is operating at 25 MVA. And the CT ratio is 300 over 5 ampere. But our generator have a different voltage value, is 15 kilovolt, while generator 2 is 5 kilovolt. And at generator 1, our OC relay plug setting is 125%, while generator 2 having a plug setting of 100%, while our TMS is similar on our generator, which is 0.75. As you can see, our circuit breaker R1 and R12, R1 and R12, our CT ratio is 150 over 5 ampere, while our circuit breaker at R21 and R23, circuit breaker R32 and R34, and also circuit breaker at R43 and R4 having the same ratio, which is 2000 over 5 ampere. But the different plug setting on each circuit breaker, which at circuit breaker R1 and R12 is 50%, while circuit breaker at R21 and R23 is 100%, while circuit breaker at R32 and R34 is 75%, while lastly R43 and R4 is 100%. Our transformer is operating at 45 MVA, and our voltage transformer is from 15 kV to 5 kV, which is a step down transformer, and all our loads are operating at 6.75 MVA. All of our equipment are having a similar TMS, which is 0.75 for the generator and all the circuit breaker. Okay, next we can see our relay operating time. For generator 1, we have the TMS and PMS insert to the standardly inverse formula to search for our relay operating time. All our equipment having a different values, but it's end up being a same calculation, a same value as the others, which is 2.228 second for generator 1, generator 2, circuit breaker R1 and R12, circuit breaker R21 and R23, R32 and R34, and also finally R4 3 and R4, all having the same 2.228 seconds for our relay operating time. That's all. Thank you.
Okay, I will explain about simulation. So as you can see, this is our diagram for simulation. They have a generator, circuit breaker, bus, load, OCR. So this is our workflow of load. As you can see, this is workflow of load. Wow! So this is my simulation for short circuit operation. This for short circuit operation. This is we use the short circuit at bus 3. As you can see, this is bar 5 and 6 is totally closed. So circuit breaker 7 is backup if the current go forward that. So next is this is high pickup current. So this is high for current is 1215.96 kilo ampere. For low is 37.52.89 kilo ampere for low. For this IDMT graph, so as we can see, IDMT relay standard is minimum time relay. So this one, which is time of operation, inversely proportional of magnitude of the fault current near the pickup value and become significant cause slightly above a relay pickup value. So I will pass to my friend. Thank you.
Hi, I'm Salam Siatra. It's the C and Zero. So our video presentation is timeline and critical path method. So first of all is the timeline of our project. So there are 9 project tasks that we need to done. So they are started on 5th of January until 18th of February. So the first project task is problem statement, then design and simulation, calculation, technical specification, critical path method, cost and standard, timeline, conclusion, and lastly is minute of meeting. So there are 3 minutes of meeting. So next is the critical path. So for problem statement, the start date is from 5th of January until 9th of January, which is we are taken 5 days. Then design and simulation from 10th of January until 10th of February, which is 32 days, which means a month. Then calculation, same goes to calculation, we take 22 days. Then technical specification, we take about 2 weeks. Then critical path method, cost and standard timeline, we are taken 10 days, which is from 5th of February until 14th of February. Then conclusion, which is the final week, 15th of February until 18th of February, taken about 5 days. Then minute of meeting is 2 weeks, which is from 5th of February until 18th of February. So the total that we are completing this project is about 44 days, which is almost about 1 month and a half. Next, for the critical path method, there are 5 tasks, which is for task 1 is use of ETAP simulation. So first of all is design process for protection scheme involve ETAP simulation, and ETAP simulation used to replicate and study fault in the distribution system, which is we apply at bus bar 3. They help in understanding for and developing suitable protection scheme and simulation stage schedule from 10th of January until 10th of February, which is 32 days. And task 2 is choice of relay. So appropriate relay selection is crucial for safe and efficient transmission line. Detailed calculation required to determine relay operating time, ROT, during fault, and then evaluate various equipment specification and brain based on short circuit assumption and calculation that we have been done. And for the calculation stage is scheduled from 10th of January until 31st of January, which is 22 days. And for the task 3 is equipment research. So through research required to choose appropriate specification and brand of equipment. So we have done a lot of review technical specification and data sheet for all relevant equipment from generator, transformer, circuit breaker, and so on. So the technical specification stage schedule is from 8th of January until 21st of January. And the fourth task is critical path method. So critical path method is important for the success of the design protection scheme project for two sources distribution system, and identify and monitor critical activity to ensure that the completion of this project within schedule, timeline, and budget, and provide a structured approach to project management and eliminate potential bottleneck. And the critical path method, cost and standard stage and timeline stage is planned from 5th of February until 14th of February. So it's taking about 2 weeks. No, sorry. It takes about 10 days. And the final task is conclusion and final stage. So the team member evaluate success of project and ensure that all objectives have been met, and minute of meeting is the final stage of our project, which is planned from 5th of February and 18th of February, which is taking about 2 weeks, 14 day. So this is important stage in documenting project and informing stakeholder of outcome and recommendation of the project. And then MOM, which is minute of meeting, provide comprehensive overview of the project, including the challenges that we have encountered during doing this project and strategies used to overcome them. So when we are encounter any challenges, so there are solutions to complete this project, and then help to ensure project is properly documented and outcome effectively communicated to all relevant stakeholders. So that's all from me. So I would like to pass to the next presenter.
Assalamualaikum and a very good evening. So my name is Aini binti ZULKARNAIN, and I will be presenting on the cost and standard for this project. So for the first equipment, it would be 15 kilovolt high voltage oil immerse transformer. So the model number is the IT0812. Its coil type is auto transformer. The winding material that it uses is copper aluminium. And then the type of this transformer is oil filled transformer, and it is from brand SW. And the output power for this transformer is 0.12 to 33 kilovolt. So for this project will be 5 kilovolt. So the standard that this transformer has is IEC 60076, GOST, IEE, and also ANSI. For the second equipment, it would be generator. So there's generator 1 and generator 2. So we would be using the same model, which is GF2000YC, and the engine that it uses is Yangdong, and then it is a brand from Yuchai, and the standard that it uses is ISO 14001, ISO 9001, ISO 45001 CE, and also CSA. So the rated power for the generator 1 would be 15 kilovolt ampere, and then the rated power for generator 2 would be 5 kilovolt ampere. Okay, for the next equipment, it would be relay. So it will be used from the brand Schneider Electric, and the standard that it uses is IEC SIT plus SITA, 10 PU standard inverse time, SIT and SITA. So for the next equipment, it will be circuit breaker. So it has a group of 4, which is R1 and R12, R21 and R23, R32 and R34, and R43 and R4. So for R1 and R12, the ratio is 150 over 5 ampere. So it's from a brand Schneider Electric. Then the model is PD3P150A T3B, and the nominal output voltage for this circuit breaker is 400 volt, and then its maximum line current is 150 ampere, and then the standard for this circuit breaker is CE and UL listed. So for the next circuit breaker, it will be the other 3 groups of circuit breaker, which is R21 and R22, circuit breaker R32 and R34, and lastly circuit breaker R43 and R4. So for these 3 groups, we will use the same ratio, which is 2000 /5 ampere, and then it is from the brand AMIR, and then the model is DW1. The nominal output voltage for this circuit breaker is 690 volt, and the maximum line current is 3200 ampere. And the standard that it uses is EN60947 and EN60947. And that's all for cost and standard. So now I will be talking about the conclusion for this project. So first of all, as we all know, the electrical system are a critical infrastructure that must be protected and reliable to operate safely and efficiently. So therefore, in achieving this, an electromechanical relay detect an abnormal circumstances and activate the circuit breakers to separate the malfunctioning components, which is vital feature of this protection. So to guarantee the effective relay performance, the correct settings such as a plug setting multiplier (PSM) and time multiplier setting (PSM) and timing multiplier setting (TMS) must be configured according to the International Electrotechnical Commission Standard Inverse SI characteristic. So this is known as SI and IEC. So therefore, selecting electrical component with adequate technical standard is crucial for power system safety and efficiency. So therefore, for this for this project, which is the generator, transmission lines, transformer, load unit, and circuit breaker, must be carefully chosen to keep the system reliable and meet the power needs and lower the risk of damage and accident. And last but not least, by paying close attention to these things or these key features right here, it is possible to build and run a power system that could meet the need of the modern society while keeping the public safe and also healthy. That's all from our group. Thank you.